Hello, welcome back to Cinderella Math. Today I'll be doing hopefully pretty quick, hopefully around 10-ish minutes or so, a video on determining if a given polynomial function has a maximum or minimum. I'm mostly going to be focused on the absolute maximum or the absolute minimum, though I will briefly bring up relative max and min. And I'm going to be doing this without calculus. So there is a completely different way. If you are in a calculus class right now, this is probably not for you. There's another way that your calculus instructor will want this done. So I'm speaking here to people in an advanced algebra 2 or in a pre-calculus class. If you know the word derivative, then this video is not for you, and I can do another video for my calculus folks. But this is pre-calculus material here. All right, let's talk just about second degree polynomials, also known as quadratics. We're very familiar with them. We've been working with them since Algebra 1. So I'm talking about our good friend x squared and all his family members, right? So we could be talking about, you know, 5, oh, my pen's being weird, sorry, 5x squared plus anything along this line, right? All of those are part of the quadratic, or why am I, sorry, my slides keep advancing when I don't want them to. Go back. There, no, it keeps going the wrong way. There we go. These are all part of the second degree or the quadratic family. And you probably don't even need to look at a graph of these, even though you could. We could go to a graphing calculator, and I will bring up Desmos here in a second. You most likely don't. You're so familiar with these. You know what they're going to look like. These will all make parabolas. Right? And they'll either be what I like to call a happy face or an upward shaping parabola, facing parabola, or a frowny, which is just a downward parabola. And again, you probably already know how to figure out which is which. If our leading coefficient is positive, so I'm looking at equation A and equation B, 1 is positive and 5 is positive, that will lead you to the happy face or the upward facing parabola. And you'll have a minimum. So that vertex is a minimum if you are working with an upward facing parabola, which means your equation, your function, has a positive leading coefficient. And looking at equation C there, he has a negative leading coefficient, so he's going to be the frowny face or the downward facing parabola, and he'll end up having a maximum for his vertex. So these we're probably very familiar with. Of course, you could pop over to Desmos if you want to get a closer, more in-depth look, but that's how you'll work with second degree quadratic parabolas. They will either have an absolute max or an absolute min. They will not have both. It'll be one or the other, a max or a min. Third degree's different story. So we're talking cubics here. So anything with the third degree. So here's equation A that I'll be referring to. It's just the parent function x cubed. And let's bring in a couple more. Let's bring in negative x cubed plus 2x squared plus x. And let's bring it. Okay. So there's our cubic family. And graphically, the parent, so I'm graphing the parent, which is A. If you do 0 cubed, that's 0. If you do 1 cubed, that's 1. If you do negative 1 cubed, that's negative 1. 2 cubed is 8. Negative 2 cubed is negative 8. And so forth. So this is not that's not the best graph there, but there we go. I can take this to Desmos in a second. There you go. Okay. That is the parent, again, not the greatest graph, but that is the parent of the cubic third degree function. There is no maximum on that because the range is from negative infinity to infinity. So there's no maximum because it goes up forever. There's no minimum because it comes down forever. Okay, so there are no absolute extrema or extrema, however you say it, on that cubic parent function. And you might be like, okay, well, that's the parent. What if we mess around with it? What if we change it? So let me write down real fast what I wrote for B and C, and let's observe those over on Desmos. Okay, so I'll put back up the parent just to make sure we graphed him correctly. So there's the parent of the cubics. Okay. And then here's what I put as the B equation. It was negative x cubed plus 2x squared plus x plus 5. I'll take off the first one, or I'll just, there we go. So there's our second one, which I called equation B, I think, on my paper. You still might be asking, oh, wait, it's got a minimum, it's got a maximum. Those are relative extrema. They are relative max and min. So if you've not learned that term in your Algebra 2 or your pre-calc class, that just means it's, so right here would be a relative min. Relative is in terms of stuff around it. So that is not the lowest the function goes, but in terms of everything around it, that's pretty low, right? Think of a roller coaster. That's like a dip in the roller coaster. And then likewise, this guy right here at the top of the hill would be a relative maximum. Again, that's not the highest we go, but compared to everything around it, that one is the largest. So this cubic here has relative extrema, both a min and a max, but it does not have any absolute max and min. Okay, because again, because our range is infinity, or excuse me, negative infinity to infinity, it's going to keep going down forever. It's going to keep going up forever. There are no maximum or absolute limits on that. Okay, and then I had one more. Let me take that one off. The example C I had was 4x cubed plus 5x minus 9. And I can zoom in. That one doesn't even have any relative. There's no bumpies. So that one has no relative extrema and no absolute. So sometimes on these, like on the second one, you will have bumpies, so you will have relative extrema, and then sometimes you won't. This one, there is no relative extrema, and the original, there's no relative extrema. Okay, but moral of the story there, all of them had no absolute. Let me go back to my slideshow here. None of them had absolute extrema. I think I can bring them back. One second, sorry. There we go. So no absolute max or min. Okay, and I want to relate this to end behavior. Okay, so if you remember end behavior, we can sort it into a couple categories. If your function is even with a positive leading coefficient, your end behavior will go up, up. So think of x squared. Okay, pretend there's a little man here. As he walks to the right, the function goes up. As he walks to the left, the function goes up. Okay, if you're even with a negative leading coefficient, that's spelled wrong, sorry, down, down. So think of negative x squared. Okay, see this guy to the right, he's going to hit the function and come down. To the left, he's going to hit the function and come down. Okay, so if you are even, you will have an extrema because this has a low point. So if you're up, up, at one point you had to hit your low point. You can kind of think of it as, you know, you're not always going to be happy all the time. So even though this little guy, he's up in both directions, at some point he had to have a bad day and he kind of hit his low point and then go back up. And the opposite's true for the little man down on the second one. He's going down both days. So again, you're going to have bad days, but at some point, this little man's going to have a good day and he's going to reach the top, right? So if you're up, at some point you had a bad day. So you're going to have a minimum. And if you're down, at some point you're going to have a good day. You're going to have a max. Okay? But if you are an odd function, so x cubed, which we just explored, with a positive coefficient, on your right-hand side you go up, on the left-hand side you go down. There are no absolute max or min. You're up forever on one side, down forever on the other. And if you're negative with an odd power, so negative x cubed, for example, you'll look something like that. On the right, you'll go down. On the left, you'll go up. And you'll still have no absolute extrema. Okay, so evens will, odds won't. And that kind of goes back to end behavior. So I'm going to talk about one more case here. I'm going to go to 4th degree, and that's the highest I'm going to go. So f of x is x to the 4th. So we know this is even. And this particular example, let's call this A, he has a 1. So he's even with a positive leading coefficient. So that means the end behavior, oops, if I could spell, the end behavior is up. So even if I don't want to go to Desmos and graph this, which I will in a second, I know on both sides of this, as x goes to the right, the function is going to go up, and as x goes to the left, the function is going to go up. So at some point, though, it's up. At some point, you had to have a bad day. It just happens. So before I even lay eyeballs on this, I can tell that it's going to have an absolute minimum. And let's use Desmos to confirm that. Let me get off of this. Okay, let me clear off all those cubics. A 4th degree, by the way, can also be called a quartic. And there he is. And we can zoom in. There's our absolute minimum. It never goes below that. And again, you can see the end behavior there going up. Let's do another quartic. I'm going to just turn that off. I'm just going to make one up here in the line 2. I'm going to do negative 8x to the 4th plus 3x cubed plus 2x, whoops, plus 2x squared minus 10x minus 1. There he is. So there is a quartic function, and that has a negative leading coefficient. So it's even power with a negative coefficient, and you can tell from the graph there that its end behavior is down. So again, both, if you kind of put your little guy in there, to the right, he'll hit the function, come down. To the left, he'll hit the function, come down. But again, not all your days can be bad ones. I hope not anyway. So at some point, if he's riding this roller coaster, he will have a good day and he will hit that absolute max. Okay? So even functions are going to have absolute extrema. Odd functions are not. They might have relative extrema, but they will not have absolute. And again, that kind of goes back to the end behavior. So I don't actually have to put eyes on this to know if it's going to have a max or min. Even though it's nice to see the graph, it's not essential. Now, if you are in calculus, you will be using derivatives to do this, and you don't really need to see the graph. And if you're in calculus, we'll be using actual calculus to find this point. Yes, it's super ugly. It won't always be like that. That's just because I made it up in my head. But so if you're in calculus, I'll do another video a different day about how to use calculus to determine all this. All right, I hope that was helpful. This was a video on knowing if a polynomial has a absolute max or min. Here, let's just do one other thing. Like before putting eyes on it, what about 5x to the 7th? It's odd with a positive power or positive leading coefficient. Honestly, the coefficient doesn't even matter. Since it's odd, it's going to go up in one way, down in the other. So you're not going to have an absolute extrema. Let's graph it and see if my hypothesis is correct. Yeah. See, up forever, down forever, no absolute. Okay, but one more. What if we change that to negative 4x to the 10th? That's even with a negative coefficient, leading coefficient. So that's going to go down, down. But again, not all your days can be bad. So at some point, you're going to have a good day. And this, I believe, will have an absolute max. Let's see if my hypothesis is correct. Negative. There he is. And yeah, there's his absolute max right there. That's the highest that goes. It never goes above that. So that is an absolute maximum. All right, now I hope that was helpful. Hope you're having a great day, and I'll see you again soon back on the channel. Bye-bye.